In this video, we'll be analyzing the graph of a function to sketch the curve. If you've not already done so, press pause to copy down these guidelines in your notes. When you're ready to continue, press play. Our first step is to find the x-intercepts of the function by letting y equals 0. So with our function f of x equals 2x squared minus 5x plus 5 divided by x minus 2, if we let y equals 0 and then multiply both sides by x minus 2, we see that 0 is equal to 2x squared minus 5x plus 5. Now this is a quadratic. To find the values for x, we'll need to use the quadratic formula because it doesn't factor. So we have x is equal to a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now if we do the math in here, we have 5 times 2 is 10, times 4 is 40. So I have 25 subtract 40, which is going to be a negative number. So our discriminant, which is this radicand under the radical, the discriminant is negative. So we will have no real x-intercepts. Our next step is to find the y-intercept by letting x equal 0. So we have y is equal to, and when x is 0, this term is 0, this term is 0, and so I have 5 over negative 2. So my y-intercept is 5 over negative 2, or a negative 2.5. Now I'm going to work these things as we go. So my y-intercept I'll plot at a negative 2.5. My next step is to find the vertical asymptotes where the denominator is equal to 0. So my vertical asymptotes will be x minus 2 equals 0 or x equals 2. If we draw that in, right. My next step is to find the horizontal asymptote, oblique asymptote, or the end behavior at negative and positive infinity. Since this is a rational function and the degree of the numerator is equal to 1 higher than the degree of the denominator, then I'm going to have an oblique asymptote. And to get the equation of the oblique asymptote, I need to do the division and ignore the remainder. So I have x minus 2 is my divisor, and then 2x squared minus 5x plus 5 as my dividend. Now you could do this with synthetic division as well, since this is just x minus a number, but I'm going to do it with long division. So I need to put a number up here so that when I multiply that by x, I'll get 2x squared. So my number is 2x. And then I'm going to multiply. 2x times x is 2x squared. And then 2x times negative 2 is negative 4x. My next step is to subtract. Algebraic subtraction, we want to change the sign and add. So this 2x squared right here will become a negative 2x squared. And this negative 4x will become a positive 4x. These terms cancel. I have negative 5x and a positive 4x is a negative 1x. And then bring down my next term. Now I can continue. I need a number that I can multiply by x to get negative 1x. So I'll have negative 1. Negative 1 times x is negative 1x. Negative 1 times negative 2 is a positive 2. And then I can just stop at this point because I ignore the remainder. So my oblique asymptote is y equals 2x minus 1. So this means my asymptote has a y-intercept of negative 1 and a slope of 2. Let me draw that in. Y-intercept of negative 1 and a slope of 2. Up to my next step, if I have a horizontal or oblique asymptote, and I do have an oblique asymptote, decide if the graph crosses it by setting f of x equal to the equation of the asymptote and solving for x. So f of x is, so I'll just write cross here. F of x is 2x squared minus 5x plus 5 divided by x minus 2. And I want to set that equal to my equation of the oblique asymptote, which is 2x minus 1. And then I'm going to solve for x. Let's multiply both sides by x minus 2. This will cancel. And I have 2x squared minus 5x plus 5 equals, the first here, 2x times x is 2x squared. The outers is negative 4x, and the inners is a negative 1x, so that's a negative 5x. And then negative 1 times negative 2 is 2. So my 2x squareds cancel, and my negative 5x's cancel. I get 5 equals to 2. And I know that that's not true, so does not cross. So basically what that means is that my graph is not going to intersect this oblique line at all. And we know it cannot cross the vertical line because that's where we would have division by 0. So the graph won't cross any of those dotted lines. As far as symmetry goes, we have no symmetry. So that's not going to help us any. And let's find our derivatives. And our first derivative, we have x minus 2 times 4x minus 5, subtract, and then the numerator, 2x squared minus 5x plus 5 times 1 over the square of the denominator. Alright, to set this equal to 0, and then simplify, we're going to have to use FOIL here, so 4x squared negative 5x and a negative 8x is a negative 13x, and then plus 10, and then distribute the negative minus 2x squared plus 5x minus 5. This simplifies to 2x squared minus 8x plus 5. Right. We'll have to use quadratic formula on this again. So x is equal to 8 plus or minus the square root of 8 squared minus 4 times 2 times 5 over 2 times 2, which is 4. 5 times 2 is 10, times 4 is 40, 64 minus 40. So x is equal to 8 plus or minus the square root of 24 all over 4. So we have critical numbers. At 2 plus or minus, this is 2 root 6 over 2. And then also when x is equal to 2, because our first derivative does not exist at x equal 2. So we have 3 critical numbers. 2 plus root 6 divided by 2. This is about equal to 3.2. And then 2 minus square root of 6 over 2. That's about equal to 0.8. And then our 2. So those are our critical numbers that we'll be working with. Put our 0.8 here, our 2, and our 3.2. I'm going to use 0 for a test value in this interval. I'll use 1 as my test value in this interval, and I'll use 3 in this interval, and 4 in this interval. So our denominator of our first derivative is squared, so that means no matter what we put in for x, we're going to get a positive number in the denominator. So really all we need to do is evaluate this trinomial for each of these test values to determine the sign in that interval. So when x is 0, we have a positive 5, so first derivative will be positive in this interval. Let me enter 2x squared minus 8x plus 5 and put 1 in. And we have a negative in this interval. 3 stored in for x. And we have a negative in this interval. And then 4 stored in for x. And we have a positive in this interval. Now we know that this is our asymptote. So when we change from a positive first derivative to a negative, that means that this is a max, and our point is 0.8, and then some y value. I'm going to have to calculate that with my original function. So 2x squared minus 5x plus 5 divided by x minus 2. And I need to put, now it wasn't 0.8, it was 2 minus square root of 6 over 2. So 2 minus square root of 6 divided by 2. And I'm going to store that in for x and see what my y value is. So it looks like it's about negative 1.9. Alright, then also when our first derivative changes from a negative, so our slope of our tangent is negative, and then changes to positive, we have a minimum. So this is going to be a min, and the coordinates are 3.2 approximately. And let me store that. It was 2 plus square root of 6. And I'm storing that in for x. So evaluating our function then at that point gives us about 7.9. So these are some, let me go ahead and put these on my graph. .8 right about there, and then a negative 1.9. So right about here is going to be our max. And then our min, 3.2. and 7.91. So right about here, that's going to be the min of our graph. At this point, we should have enough to graph. If we did our second derivative, we would find that it's negative, which means concave down for this interval, and then we would find it's concave up for this interval. So I'm going to go ahead and sketch my graph. This was a minimum up here, so it has to come up and hug this asymptote, and then come up and hug that one. This one also has to go through these 2 points, and then